Hi guys, I welcome you to my YouTube channel, Learn Physics with IBM, and today I got the courage to solve past paper questions of multiple choice questions for the May June series 2023, and I would like to take you to the question paper directly. So without wasting time, this is the question paper that I'm solving, and I'll start solving it right away. So I'll select my pen. Okay. So this is Cambridge International AS and A-Level Physics multiple choice questions. It's 9702/11. This is May, June 2023. The paper is 1 hour and 15 minutes. I will try to use 1 hour and 15 minutes. So I will not go through the instructions, but this paper carries 40 marks. So we are used to the data, we are used to the formula. Question number 1, which unit is not an SI base unit? So we know that ampere is a unit for current, that is SI base unit. Kilogram is a unit for mass, that is SI base unit. Coulomb is a unit for charge, and charge is not a base quantity, so Coulomb is not a base unit. So the answer here is C. What is the best estimate of the number of atoms in a piece of metal volume 50 centimeters cubed? So first of all, we are going to make an estimate of the diameter of the atom or the radius of the atom. I think the diameter or the radius of an atom is approximately 10 power minus 10. You must have mentioned the scale of things in particle physics. The radius of an atom is approximately 10 power minus 10 in meters. It is of that order. If I change this in centimeters, I have to multiply by 100, so it becomes 10 power minus 8 in centimeters. So we know that the volume of a sphere, if we assume that the atoms are spherical, the volume of a sphere is 4/3 pi r cubed. So I will simply substitute to find the volume. So this is going to be 4 divided by 3 pi. Then where there is r, the radius is 10 power minus 8, but this is raised to power 3. Okay, so that is going to be the volume. So if I want to find how many atoms are in the volume of 50, so I will divide 50 by this volume here. So the number of atoms is going to be 50 divided by, when I divide by this, the 3 goes up, so it is times 3. In the denominator, it is 4 pi times 10 power minus 8, and this is going to be power 3. When I press my calculator, so this is going to be 50 times 3 divide by open brackets, this is 4 pi times, so it is 4 pi times open another bracket. I'll simply say 1 exponent minus 8, but this is raised to power 3. So this is giving me 1.19 times 10 power 25. So this is 1.19 times 10 power 25. So the power of the answer is 25, and when I look at the answers here, I see that the most appropriate answer is B. A copper pipe has a diameter of 42.0203 millimeters. A builder measures the diameter of the pipe 5 times using a digital caliper. The measurements are shown in this table. You should be able to see the table. What describes the builder's measurements? So first of all, when you look at the measurements, they are very close to each other, so we can say they are precise. But remember, we expect that the diameter is 42.03, and you notice that the average of all these values is far from that value. The average of all these values is not this value, or is not very close to this value, so it means they are not accurate. They are not accurate. Remember, precision is how close the measurements are to each other, and accuracy is how close the average of the values is to the true value. If you try to find the average of this value and it is not very close to the true value, then they are not accurate. So they are not accurate, but they are precise. So the answer is going to be automatically D. They are precise, but they are not accurate. Two forces, each of 10 newtons, act at a point P, as shown. The angle between the directions of the forces is shown. So this is the angle. What is the magnitude of the resultant force? So we can complete the parallelogram by drawing the vectors to completion. So I'll transfer the vector of 10 newtons here, and I'll also transfer the other vector. So that I complete the parallelogram. But when of course, by common sense, the resultant is going to be here. So this is going to be the resultant. So if you want to use the cosine rule, it means you must know these angles. So if this is 120, this angle is 120. So this angle is going to be 60 degrees because this is also 60 degrees. So let's say this is the resultant. By the cosine rule, r squared will be equal to a squared plus b squared minus 2as cos of the angle. So I'll say the resultant r is equal to the square root of a squared, which is 10 squared, plus b squared, which is also 10 squared, minus 2 times 10 times 10 cos of 60. So I will press my calculator. 10 squared plus 10 squared minus 2 times 10 times 10 cos of 60. That is the answer. When you find the square root of 100, it is 10. So it means r should be equal to 10. This means the answer is going to be B. And one object moves directly from P to R. So that means the object moves in following this path. This is one object, P to R. In a shorter time, so the time is not the same. Let's say the time here is T1, following P to R. In a shorter time, a second object moves from P to Q to R. So I'll change the color here. So another object follows P to Q and then to R. So this is following P to Q then to R. Let's say this time is T2, and we are saying in a shorter time. So that means T2 is less than T1. So it most likely, because PR is smaller than PQR, most likely it was moving faster along PQ. The second object was moving faster. So which statement about the two objects is correct for the journey from P to R? Number one, they have the same average speed. Remember, average speed is going to be equal to the total distance divided by the total time. They cannot have the same speed because one, the distance is not the same, and two, even the time is not the same. So they don't have the same average speed. So this is out. In fact, PQR has more speed because it takes a shorter time in a longer distance. So this is out. Then they have the same average velocity. For velocity, the displacement is the same because displacement is the shortest distance between the initial point and the final point. The displacement is the same, but the time is not the same. The velocity is going to be the displacement divided by the time. I'm saying the displacement is the same because displacement is the shortest distance between the starting point and the final point. But remember, the time is not the same. T2 was less than T1. So it means the velocity is not the same. So that is also out. They have the same displacement. Of course, they have the same displacement because displacement is the shortest distance between the first point and the final point. So the answer is going to be C. They travel the same distance, not at all. Distance is a scalar quantity. The distance of the first one is P to Q directly. The distance of the second one is P to Q, then to R. So that means this distance here is bigger than the other distance. So the distance is not the same. So the correct answer is going to be C. A ball is kicked so that it has an initial velocity of 12 meters per second at an angle of 50 degrees to the horizontal ground. Assume that air resistance is negligible. we are assuming air resistance is negligible. That means the acceleration is the acceleration due to gravity, which is constant. What is the maximum height above the ground that is reached by the ball? The maximum height. So first of all, we know that since air resistance is negligible, the acceleration is going to be 9.81. Because it is kicked above the ground, it goes above the ground, then this is going to be a minus. Therefore, using v squared equals to u squared plus 2as. We know that at the highest point, or at maximum height, v is 0. So 0 squared is going to be equal to initial velocity. So I'm going to consider vertical motion. I'm considering v in the vertical. When I put subscript y, I'm meaning velocity in the vertical. Or I'm taking motion in the vertical. Initial velocity in the vertical, I will resolve 12 to the vertical, and that will be 12 sine of 50. So this will be 12 sine of 50, but this is going to be squared minus 2 times the acceleration, which is going to be 9.81. Note that I bring in the minus because it moved against gravity, so g is minus, then times h. So when I make h the subject, h is going to be 12 sine 50, or this is squared, divided by 2 times 9.81. When I press my calculator, 12 sine of 50, and this is squared, divided by open brackets 2 times 9.81. So this is giving me this is squared. I will repeat this, 12 sine of 50 squared. Sorry, I have to square the whole thing. Sine of 50, the whole of it is squared. Then I divide this by 2 times 9.81. So this gives us 4.3. So this is 4.3 meters. So the answer is C. A camera drone of mass 1.2 kilograms hovers at a fixed point above the ground. The drone has 4 propellers. It has 4 propellers. In a time of 1 second, each propeller pushes a mass of 0.4 kilograms of air vertically downwards. Assume that air above the propeller is stationary. What is the speed of the air leaving each propeller? Okay, so what is the speed of the air leaving each propeller? So here I'm going to simply use Newton's third law. So let's assume the force coming from each propeller is given by F. I'll quote F air. But these forces are going to act vertically upwards. So in equilibrium, it means the weight of the weight of the whole object W, which acts downwards, should be equal to the total force of the air of the air from the propellers upwards, which are force, I'll say, equals to 4 times F. I've just called F from due to the air from the propellers. So that is by Newton's third law. So it means by Newton's third law, I'll quote, we normally write N3 to mean Newton's third law. The weight W is equal to 4 times that force. But again, by Newton's second law, the force is equal to mass, or it is the rate of change of momentum. So this is going to be the mass. This is going to be 4 times the mass of the propeller, of course, times change in momentum, so times V minus U divided by T. So if I assume that the air above the propeller is stationary, and again we want what is the speed of the air leaving each propeller. So final will be 0, initial is what we want to find. So I can just, of course, I'm going to ignore the minus, but even if I include the minus here, so let's say final velocity is 0, and I want to find the initial velocity of the air leaving the propeller. So the weight, remember weight is equal to mg. So the weight is going to be 1.2 times 9.81 being equal to 4 into the mass of each propeller is 0.4. This was mass of the propeller. This was mass of the hover. The camera drone of mass that. So this is mass of the drone. So this is 4 into mass of the propeller, which is 0.4. Then into final velocity is 0 minus u divided by t. So this is divided by t, where t is actually 1 second. So this is divided by 1 second. So I'm going to get u, whether it is negative, it doesn't matter, the magnitude is the same. So I'm making u the subject. U is going to be 1.2 times 9.81 times 1 divided by 4 times 0.4, that is 1.6. I've just ignored the minus, but you can add it there if you want. So pressing my calculator, 1.2 times 9.81 divided by 1.6. So this gives me 7.36. 7.36. So the answer is going to be C. A box rests on the earth as shown. Newton's third law describes how forces of the same type act in pairs. One of the forces of a pair is the weight W of the box. Which arrow represents the other force of this pair? Now, according to Newton's third law, the forces must be of the same kind. They must be of the same nature. They must be of the same nature. And if we consider that point, therefore the answer is going to be A. If one of the forces is weight is the pull of the earth. The pull of the earth is gravity on the object. Then the object should also exert a pull due to its gravity. And the pull on the earth due to the object is the force of the object which acts from the center of the earth. So the answer is going to be A. I say these two forces must be of the same kind. They must be of the same nature. And if one of the forces is weight, where weight is the pull of the earth on the object, the other force should be the pull of the object on the earth. That means the answer is going to be A, because the pull of the object on the earth acts at the center of the earth. Since the weight of the object, which is the pull of the earth on the object, acts at the center of the object. So the answer is A. A small ball is held at the surface of liquid in a container. The ball is released from rest and falls through the oil. The ball has velocity v, a viscous drag of force F acts on the ball. Which graph could show the variation with v of F? Which graph could show the variation of v with v of F? So let's think of the ball falling in a liquid of oil. So it has weight downwards, and there's a drag force upwards, which is F. Of course, as it is falling, the speed v increases initially, because before it starts falling, the drag force is 0. So the speed increases, but as the speed increases, the drag force also increases. The drag force increases with the speed. So F increases as v increases. For those who are very good at this, your teacher must have mentioned that the frictional force is directly proportional to the square of the speed, which means this graph cannot be a straight line. The frictional force is directly proportional to the square of the speed. So let's just use inspection. As v increases, F increases as a square of v. F increases as a square of v. That means C is wrong, because C is showing that F increases and then decreases. D is wrong because it shows that as V increases, F decreases. B is showing that as V increases, F increases, and then this part is showing it is decreasing. So of course the answer is A, but if you don't see that is A, you can check. Let's say F is equal to K times V squared. And let's say K is a constant, which is 1. Let's just make K to be 1. Suppose if we put in V equals to 0, 1, 2, and 3, what are the corresponding values of F? So it means if we put in V as 1, 0, 1, 2, 3, I will stop at 3, then F will be equal to, when V is 0, F is 0. But when V is 1, F is 1. And when V is 2, F becomes 4. When V is 3, F becomes 9. So you notice that F increases more rapidly F increases more rapidly as V increases. In fact, if when V is 4, F will be 16. So you see that this curve is going upwards. The gradient must be increasing. If you try to plot such a graph of of F against V, you notice that the graph goes upwards. So it is an increasing gradient. Okay, an object of mass m moving at a speed u along a frictionless horizontal surface collides head-on with a stationary object of mass 4m. So this is before the collision. After the collision, the object of mass m rebounds. That means it moves in the opposite direction along its initial path with a quarter of its kinetic energy before the collision. What is the speed of the object of mass 4m after the collision? So number one, I will use conservation of momentum so that we find the speed here. So by conservation of momentum, we know that momentum is equal to mass times velocity. Let's say the initial momentum P1 is equal to m times u plus 0 because the other one was at rest. Then the final momentum after the collision, call it P2. Because the one of mass m rebounds, its momentum is going to be negative m. Let me call it final velocity Vx. Then plus the other one of mass 4m, its momentum is 4m times its velocity. I'll call its velocity Vy. So after rebounding, no, I will need that space. I will need this space. So let's say after the collision, the velocity of this one is Vx, the velocity of the other one is Vy after the collision. By conservation of momentum, total momentum before collision should be equal to total momentum after collision. So I will have that mu is equal to minus mvx plus 4m vy. So m cancels out. And if m cancels out, I want you to see that u is going to be 4 times vy minus vx. That is one equation. Now let me consider kinetic energy. Before the collision, the mass m has kinetic energy, which I'm going to call E1, is going to be a half m u squared. And after the collision, they have told us that its kinetic energy is a quarter its initial kinetic energy. So after collision, its kinetic energy is E2 is going to be a quarter of a half m u squared. But remember, kinetic energy after collision is going to be a half m vx because its velocity after collision is vx. So this is the same as a half m times vx squared. It's the same. So I will cancel out m cancels out, a half cancels out, and I remain with the fact that vx squared is going to be u squared divided by 4. When I find the square root, I see that vx is going to be u divided by the square root of 4, which is 2. So the final velocity, the velocity of the mass m after collision is u divided by 2. It is u divided by 2. Okay, but I want the speed of 4m after the collision. That is, I want Vy. I want Vy. So I will substitute in this equation here. I'll go and substitute in that equation there. So u equals to 4 times Vy minus, where there is Vx, I'm putting there u divided by 2. So I just simplify this. This will be twice u equaling to 8 Vy minus u. Collecting the like terms, taking u the other side, it becomes 3u equals to 8 Vy. And then dividing, Vy is going to be 3u divided by 8. This makes the answer to be automatically D. The driver of a car applies two parallel forces to a steering wheel as shown in the figure here. So this is a question about torque or moment. Each force has magnitude 15 newtons and acts in the direction shown. The steering wheel has a diameter of 0.40 meters. What is the torque on the steering wheel? Remember, torque is the product of one of the forces times the perpendicular distance if we have two equal but parallel forces. But now we need the perpendicular distance. The easiest way to do this is to resolve the 15 newtons in this direction, and this will be 15. Using 65 degrees to be 15 sine of 65. And we shall also resolve this 15 newtons perpendicularly or upwards and still to be 15 sine of 65. Now they constitute a couple whose perpendicular distance is 0.40 meters. Therefore, the torque of such a couple will be the product of one of the forces, which is 15 sine 65, times the perpendicular distance between the two forces, which is 0.40. So the torque here is 15 sine 65 times 0.40, which is 5.4. So this is 5.4. So the answer here is going to be D. The farmer is trying to lift the corner of a large water tank. She uses a metal rod as a lever. The vertical force from the farmer is constant, so F is constant, and is always applied at the end of the rod, which change must increase the upward force on the water tank. We want to increase the upward force of the water on the water tank. So we know that the moment of a force is the product of the force and the perpendicular distance. So the force here is going to be the force on the tank. I'll call it Ft. We want we want to increase the upward force on the tank. So to make F bigger, then remember this is times the distance of the tank from the pivot. So if I want to make F bigger, definitely I must reduce the distance. I must reduce the distance between the tank and the pivot. If the force of the farmer is the same, I must reduce the distance between the tank and the pivot. To make Ft bigger, I must reduce the distance between the tank and the pivot because they're inversely proportional. So it means I must move the pivot closer to the tank. That means I move the pivot to the left. So use a longer rod and moving the pivot closer to the tank. So the answer is going to be A. If I move the pivot closer to the tank, it means I am going to produce a greater force on it because the force is inversely proportional to the distance from the pivot. And when the distance becomes smaller, the force is going to be greater. So the answer is A. The diagram shows a ball of weight W hanging in equilibrium from a string. The string is at an angle theta to the vertical. The tension in the string is T. The ball is held away from the wall by the horizontal force P from a metal rod. Which relationship between the magnitudes of T, P, and W is correct? So here I'm just going to draw a vector triangle for this. So we have the weight acts vertically downwards. This is W. On the head of the weight, I add the tail of P without changing its direction. So this is P in the horizontal. Without changing the direction of the tension, so the tension is going to be along this side. You see my ruler is parallel to the tension, so this is going to be for the tension. So you see that this is a right angle triangle where this angle is going to be theta, I think, because when I take this one vertically upwards, this angle is theta. So that angle is going to be theta, or when I take this one vertically, when I continue this one downwards, this angle is theta. So that angle is going to be theta. So this is a right angled triangle, so we can also use Pythagoras theorem to find a relationship for P, T, and W. So we can say W squared plus P squared is equal to T squared by Pythagoras theorem. So the answer here is going to be C. Which expression for pressure is correct? We know that pressure is the force acting normally per unit area. So pressure is the force acting normally per unit area. This means the answer is automatically A. Pressure is the normal force acting per unit area. A ball has a mass of 0.5 kilograms and volume 1.3 times 10 power minus 3. The ball is floating in equilibrium on still water. The two forces that act on the ball are its weight and the upthrust due to the water. The density of the water is 1.0 times 10 power 3. What is the percentage of the volume of the ball above the surface of the water? So first of all, when it is in equilibrium, the upthrust is equal to the weight when it is in equilibrium. But remember, the upthrust is actually the density of the liquid times the volume of the liquid which is displaced, which is the same as the volume of the object submerged. So this is the volume which is submerged. I will use submerged, then times G. And this should be equal to the weight, where the weight is the mass of the ball. This is the mass of the ball times G. So G cancels out, is not necessary here. So it means the volume submerged, the volume which has been submerged, is going to be the mass of the ball, which is 0.5 divided by the density of the liquid, which is the water, that is divided by 1000. So this is the volume submerged. So this is 0.00, I think it is 0.5. That is the volume submerged, meters cubed. But the question is, what is the percentage of the volume of the ball above the surface of the water? What is the percentage of the volume? Let me just find the fraction submerged, or the percentage submerged. Percentage submerged. Since I have the volume submerged, I'm finding this percentage submerged. So it will be 0.0005 divided by the volume of water, which is 1.3. I mean the volume of the ball, which is 1.3 times 10 power minus 3. Then I multiply this by 100. This is the percentage which is submerged. So this is 0.0005 divided by 1.3 exponent minus 3. Then times 100. So this is 38%. So it is 38% which has been submerged. But we want the percentage of the volume of the ball above the surface. So above the surface, percentage which is above is going to be 100% minus 38%, which is going to be 62%. So the answer is going to be C. The percentage which is above the surface of water is 62%. Note how I got the volume submerged. Upthrust is equal to the mass of the liquid times G, where the mass of the liquid is the same as the density of the liquid times the volume which is displaced, the volume of liquid displaced. So I want to make this clear for the starters. Upthrust is the mass of the liquid displaced times G. The mass of the liquid displaced is the density of the liquid displaced times the volume of the liquid displaced times G. But then the volume of the liquid displaced is the same as that part of the ball which is the same as the volume of the ball which is inside the water. So this is the same as the density of the liquid times the volume of the ball which has been submerged, then times G. That's why I said density of the liquid times volume submerged times G. A man sits on a buggy that is pulled along by a wire attached to a kite. The wire is at an angle of 40 degrees to the horizontal and has a constant tension of 200 newtons. The man and the buggy travel a distance of 20 meters along a straight horizontal path. So the distance traveled is 20 meters. Let's say that it travels in this direction through 20 meters. The wire and the path of the buggy are in the same vertical plane. What is the tension? What is the work done by the tension force on the man? So I have resolved the tension in the horizontal, and this will be 200 cos of 40. So we know the work done is equal to the product of force and distance in the direction of the force. That's why I had to resolve. So the force is 200 cos 40 in the horizontal times the distance in the horizontal, which is moved in the horizontal. So this is going to be 200 cos of 40, then times 20. So this gives me 3064, which is 3.1 kilo, 3064 joules, which is 3.1 kilojoules. So the answer is going to be B. A ball is thrown vertically upwards from the surface of the earth. Which statement describes the energy of the ball as it rises through the air? It is rising through the air. That means there is acceleration due to gravity. There is acceleration due to gravity, but because it's rising through the air, there is friction or air resistance. Air resistance is there. So let's look at the ball. Its weight is acting vertically downwards. It is going upwards, so air resistance is downwards. Force due to air resistance is downwards. What does that mean? Of course, since it is going upwards, of course the force due to air resistance decreases because it doesn't speed up. But the velocity decreases to zero at the highest point, which means as it goes upwards, the kinetic energy decreases to zero at the highest point. But then as it goes upwards, H increases. And remember, potential energy is equal to mgh. So we can say potential energy increases. So we should look at those two. Let's see what is given here. The kinetic energy of the ball decreases. That is true. The kinetic energy of the ball decreases. That is true. The kinetic energy of the ball increases. So this one is wrong. The total energy of the ball increases. This is also wrong because total energy remains constant. Total energy is always conserved. Total energy is always conserved. It does not increase. The energies change from one form to another, but the total remains the same. So we have to choose between A and B. The kinetic energy of the ball decreases, which is true. As the gravitational potential energy decreases, we have seen the potential energy increases. So the answer is going to be B, not A. A lamp is suspended in equilibrium from a fixed support by 3 long identical wires. The weight of the lamp causes each wire to have an extension of 0.4 centimeters. Now these 3 wires are in parallel. If you look at them, they're acting as if they are in parallel. The height h of the lamp above the floor is measured. The middle wire suddenly breaks, so we remain with the 2 wires in parallel. And the lamp falls a small distance as the extension of the remaining 2 wires increase. The wires obey Hooke's law. When the lamp is in equilibrium, the height h of the lamp above the floor is measured again. What is the difference between the two values of h? Okay. So let's first of all consider 2 wires in parallel, 3 wires in parallel. I'm going to consider the extension of one wire to be x. Let one wire extend by x if it is used alone. If one wire is used alone, let its extension be x. Now, since there are three, in the formation of solids, you saw a combination of springs. When springs are used in parallel, the extension decreases. If there are two springs, the extension was x over 2. If there were three springs, the extension was x over 3. If you had 10 springs, the extension became x over 10. So the extension went on decreasing depending on the number of springs. Similarly, since we have three wires in parallel, so for three wires in parallel, if one wire extends by x, now if there are three, the extension reduces by a fraction of 3. So the extension is going to be x divided by 3. But they said the extension was 0.4. So x divided by 3 is 0.4 centimeters. So this means, or this implies, that x is going to be equal to 0.4 times 3, which I think is 1.2 centimeters. So the extension of one wire alone is 1.2 centimeters. Now this one of the wires breaks suddenly. We remain with the two wires. So two wires in parallel. Two wires in parallel. So for two wires in parallel, the extension will therefore be x divided by 2, which will be 1.2 divided by 2, which I think is 0.6 centimeters. So it means if there are two wires, their total extension is 0.6 centimeters. If there are three, the extension was 0.4 centimeters. So what is the difference? The difference must be equal to the change in h. So the change in h is going to be 0.6 minus 0.4, which is 0.2 centimeters. So the answer is going to be A. The force extension graph for a spring is shown. What represents the work done to extend the spring? Work done. Of course, we know that work done is equal to the area under the graph. This is what gives us a half F times x, where x is the extension. But remember, Hooke's law, F is equal to kx. So this could also be a half kx squared. So let's check what is given. The area under the graph. I think the answer is A without wasting time. The gradient, that is not true. The gradient will be, I think the gradient would be the constant k. The reciprocal of the gradient, that's not true. Twice the area, that's not true. The answer is A. In an experiment, a student uses a microphone and a cathode ray oscilloscope to analyze a sound wave. The diagram shows the trace on the screen of the CRO. The student is expecting a sinusoidal wave, that is a sine curve, to be shown on the screen. Which changes should the student make to the time base and the Y gain of the CRO so that the screen shows a continuous trace for one complete cycle of the waveform? If I want the amplitude, I will need the representation of the amplitude. That is, if I want one cycle, I need this representation of the amplitude, that is A, times the Y gain. So this is the A times the Y gain. The representation of the amplitude on the screen times the Y gain, which I'm going to call Y. So because we see that the amplitude is not fitting on the screen, so I must adjust so that A becomes smaller. So I must make A to become smaller. The only way I can make A to become smaller is if I increase the Y setting. The only way I can make A to become smaller for the same amplitude which is fitting on the screen is if I increase the Y gain. So to make the amplitude smaller to fit on the screen, to make the representation smaller to fit on the screen, I must increase the Y gain. So the Y gain must increase. So this one is wrong, this is wrong. Then for the time-based setting, remember the period is the representation, I'll call it L, representation, or the length representing one cycle on the screen times X, where X is the time-based setting. We also see that one cycle is not fitting. The length representing one cycle is L, We want L to fit on the screen. So we must reduce L. The only way we can make L to be smaller to fit on the screen is if we increase the time-based setting. Therefore, it means the time-based setting must increase and the Y gain must also increase, so the answer is going to be D. The graph shows the variation with the time of the displacement of a particle in a progressive wave. Two measurements x and y are labeled. Of course, x must be maximum displacement, that is amplitude. The distance between two successive corresponding points, that is wavelength. Or time between two corresponding points, that is period. So x is amplitude and y is the period. So the answer is A. A car travels at a constant speed along a straight line PQ. A loudspeaker attached to the car emits sound of constant frequency F. A stationary observer is at point O. What does the observer hear as the car moves from P towards Q? If I consider the car when it is at this point here, the waves are going to be in this direction. What does that mean? The observer here will not hear anything because the waves are in this direction. So it means that Q, the frequency here will be small. Because at Q, it means the frequency decreases as we move towards Q. Because when you are at Q, the waves will be this side. That means the waves would almost be not spreading to the observer, or a fewer waves will be spreading to the observer. But as the car is coming more, as the car is getting closer, the distance is decreasing. So we expect the frequency to be higher than F. But as the car gets closer to Q, the frequency will be less than F. The frequency is initially higher than F. The frequency must be higher than F, but then it decreases. So because from F, observe the frequency is equal to V over V plus or minus U times F, which is the constant frequency. This is constant. Now, if it is moving towards the observer, we use a minus. So it is going to be F naught equals to V divided by V minus U times F. So that means F naught must be greater than F. But as we move towards Q, even though F naught is greater than F, it decreases because at Q, the waves are not moving towards the observer, they are actually moving this side when the observer is at Q. So that means it is higher than F, but it decreases. So we say a frequency more than F, that decreases as the car moves from P to Q, because at Q I have said the waves will not be moving towards the observer. So the frequency is higher than F because, first of all, moving from P to Q, the distance between P and O decreases. That's why I use the V minus, so that F naught is bigger than F. But then F naught decreases as we move from P to Q. So the answer is going to be C. Some sources of electromagnetic waves in free space are listed. We have radio waves, a source of X-rays. We have a 30mm radar transmitter. We have a light emitting diode that emits a red light. So this is visible spectrum. Which list gives the source in order of increasing wavelength from left to right of the waves? So to remember these waves, reads mother is visiting, Uncle Xavier's garden. So this is radio waves, microwaves, infrared, visible spectrum, ultraviolet, X-rays, and gamma rays, in that order. This one has the highest wavelength. So since we are writing in increasing order of wavelength, radio waves have the highest wavelength. So one should come at the extreme end. So it means automatically the answer is C, because radio waves have the highest wavelength. So the answer is going to be C. 1 is coming to the end. Oh, you can even check for the first. For the first, X-rays have the smallest wave because red is visible. Radar is also radio waves, but the frequency is 30 millimeters. The highest frequency is, I think, 1 times 10 power 4 meters for radio waves. So 30 millimeters could be somewhere here between radio and microwaves, between 1 times 10 power 4 to 30 millimeters. But 30 millimeters, I think, is microwaves. 30 millimeters, that is 30 times 10 power minus 3, which is 3 times 10 power minus 2. That is most likely microwaves. So X-rays should be having the smallest wavelength. So this should be the first on the list. Since we are talking about increasing, X will be the lowest, radio waves will be the highest. So the answer is going to be C. Okay, so a vertical polarizer beam of light is incident normally on a polarizing filter. It is incident at 90 degrees. The transmission axis of the filter is at an angle of 40 degrees to the horizontal. So I will need the angle between the transmitted light, the transmitted beam, and I need the angle between the transmitted beam and the horizontal. So I need this angle here, and this angle is going to be, I think, if this is 90 degrees and this is 90, this angle is going to be 50 degrees. So since I know that intensity is directly proportional to the amplitude squared, and intensity therefore is going to be constant times amplitude squared. Let the incident intensity be I naught, which is going to be K times A naught squared. And let the transmitted intensity, but we also remember by Morse's law, according to Morse's law, the transmitted intensity I is equal to I naught cos squared theta. So theta is the angle through which the angle through which the transmission axis has been rotated, or the angle through which the filter has been rotated from the original position. So this is, I think this angle is 50, because if this is 90 and the other is 90, then this angle is going to be 50 because this is a straight line. The angle sum should be the angle sum should be 180 degrees of a straight line. So I'm going to just relate these two. So intensity transmitted is equal to Ka squared, which is equal to that. So the ratio is going to be Ka squared divided by Ka naught squared. This is going to be equal to Ka squared is the same as this. So this is going to be I naught cos squared theta divided by I naught. No, this is equal, this goes to this. So I naught cancels out, K cancels out, so I have that A over A naught squared is simply going to be equal to cos squared theta. So that means cos theta is the angle between the transmitted beam and the origin and the horizontal. So it means A over A naught is going to be equal to cos of 50, which I think cos of 50 I think that is 64. So this is 0.64. 0.64. So this is 0.64. Okay, alternatively, we find cos of 180 This is 180 plus 50. This angle would be 50. So this is 50 plus 180. That is 50 plus 180, which is 130. Of course, we would get the cos, and that would be minus, but that is still the same magnitude. So the answer is that. So the answer is going to be 0.64, which is A, which is C. Two progressive waves meet at a point. Which condition must be met for superposition of the waves to occur? Of course, for superposition of the waves to occur, the waves must be of the same type, of the same kind, moving in opposite directions. But even when they don't move in opposite directions, still superposition can occur. You have seen waves moving in the same direction and they meet at a point. So this is not a major condition for superposition. The waves must meet in phase. They may not meet in phase. That's why we can have destructive and constructive interference. The waves may not be of the same, may not maintain a constant phase difference, but as long as they are of the same type, then superposition will occur, because for superposition, the resultant displacement is the algebraic sum of the individual displacements of the waves. So the waves could be in the same direction and meet. Opposite direction just results into a stationary wave, not necessarily a superposition. So the answer is B. A string is stretched between a vibration generator and a fixed point. When the vibration generator is vibrating at a frequency f, a stationary wave with 5 nodes is created on the stretched string as shown. There is a node at the end of the string that is attached to the vibration generator. The frequency of vibration of the vibration generator is slowly increased. What is the next frequency that produces a stationary wave on the string? Okay, so since this is a string, I'll just use a simpler method. This is 1, 2, 3, 4. The frequency the frequency Fn is equal to n times f naught for a string, where n is a whole number. So this is 1, 2, 3, 4. So this is f4. f4 is equal to 4 times f naught. So this means f naught is going to be equal to, they said the frequency shown here is f. So f naught is going to be f divided by 4. That is the fundamental. Then we want the next. The next is going to be f5. So f5 should be equal to 5 times f naught. So that means f5 is going to be 5 times f naught, which f naught is f divided by 4. So this is 5 divided by 5. I think 5 divided by 4 is 1.25. So this is 1.25 f. So the answer is going to be A. A ripple tank and a barrier with a single gap are used to demonstrate the diffraction of surface ripples on water. Initially, the wavelength of the ripples is 5 times. Initially, wavelength is 5 times smaller than the gap. Remember, for maximum diffraction, the wavelength should be approximately equal to the size of the gap, equals to the width of the gap for maximum diffraction. But here the gap is 5 times bigger than the wavelength. Which change increases the amount of diffraction? To increase the diffraction, we must make sure that the wavelength is almost the same as the size of the gap. Already the gap is many times bigger than the wavelength. So either we increase the wavelength or we decrease the width of the gap. So double the amplitude of the ripples. The amplitude does not affect the diffraction. Double the width of the gap. Okay, doubling the width of the gap. It is already big. When we double it, we again reduce diffraction. So this is out. Half the frequency of the ripples. Remember, frequency is inversely proportional to wavelength. If we half the frequency, then we double the wavelength. When we increase the wavelength, it will be very close to the width of the gap. So the answer is going to be C. Having the frequency doubles this one doubles the wavelength. It doubles the wavelength. Remember, the wavelength was smaller than the gap, so we are trying to increase it so that it's very close to the size of the gap. So that one increases diffraction. A laser produces a beam of light of wavelength 650 nanometers. The beam is incident normally on two slits that are a distance 0.12 millimeters apart. A screen is placed parallel to the slits. The bright interference fringes on the screen have a separation of 7.5 centimeters. What is the distance between the screen and the two slits? Remember, for a double slit, lambda is equal to AX divided by D. So D is what we want to find, which will be AX divided by the wavelength. So this is 0.12 times 10 power minus 3 times X. X is 7.5 times 10 power minus 2 divided by the wavelength is 650 times 10 power minus 9. So I'll press my calculator. 0.12 exponent minus 3 times 7.5 exponent minus 2 divided by 650 exponent minus 9. So this is giving me 13.8, which is approximately 14. So the answer is D. A beam of light from a laser is incident normally on a diffraction grating. Of course, we know that for diffraction grating, n lambda is equal to d sine of theta. N lambda is d sine theta. So the diagram shows a second order maximum. So small n is equal to 2. The grating has line spacing, so this is small d. The angle between the two second order maxima is 110. Angle between the two, so we have to divide it because the angle, diffraction angle theta is measured from the center, so this is 55 degrees, 55 degrees. So what is the wavelength? So lambda is going to be d, which is 1.0 times 10 power minus 6 sine theta, which is 55, divided by n, which is 2. So 1 exponent minus 6 times sine of 55 divided by 2. So this is 4.1 times 10 power minus 7. 4.1 times 10 power minus 7 in meters. So the answer is A. The electric current in a metal wire is 4 milliamperes. How many electrons pass a fixed point in the wire in a time of 10 hours? So we know that current is the rate of flow of charge carriers, that is charge over time, where this is the number of electrons times the charge of each electron divided by time. So we want N. So it means N is going to be I times T divided by E. So I is 4 times 10 power minus 3 times 10 hours, that is 10 times 3,600 to change it to seconds. The charge of one electron is 1.6 times 10 power minus 19. So I have 4 exponent minus 3 times 10 times 3,600 divided by 1.6 exponent minus 19. So this is 9 times 10 power 20. So the answer here is going to be C. What is the definition of the potential difference across an electric component? Of course, we know that potential difference is energy per unit charge. The energy converted from electrical to thermal per unit charge. So it is energy transferred per unit charge. So the answer is B. Which graph shows the IV characteristic of a filament lamp? So these are graphs of I against V. I is equal to V divided by R. So if I have I against V, it means the gradient is equal to 1 over R. The gradient is 1 over R for I against V. Now let's look at a filament lamp. If a filament lamp, as I increases and V increases, the temperature increases. So as the temperature increases, the resistance of the filament wire also increases. But as the resistance increases, it means the gradient must decrease. So we should have a decreasing gradient. This one is a constant gradient, increasing gradient. So we have between D, A is also an increasing gradient. So the answer is automatically D. I is V over R. And from this expression, the gradient is 1 over R. But for a filament lamp, as temperature increases, the resistance increases. And as the resistance increases, it means the gradient should decrease because they are inversely proportional. So the graph D shows a decrease in gradient because the line is becoming horizontal. So the answer is D. A metal wire has length 2.5 meters, cross-sectional area 4.5, exponent minus 6 meters squared. The resistivity of the metal wire is 3.5, exponent minus 7 ohm meters. The wire is stretched so that its length increases to 2.65 meters. The wire remains cylindrical and the volume of the wire remains constant. V is remaining constant. Okay. What is the change? What is the change in the resistance of the wires? So I'll utilize this point here. First of all, I know resistance is equal to rho L over cross-sectional area. And I know that the volume of the wires, let's say the first wire has area A1, length L1. So the volume of the first wire is A1, L1. Remember, the volume is the same, so this should be the same as A2, L2. Since I have the first cross-sectional area and the first length, and the second length, I can find the second cross-sectional area. So it means A2 is going to be A1, L1 over L2. I'll substitute. L1 is 2.5. A1 is 4.5 times 10 power minus 6. L2 is 2.65 meters. So this is the area of the second wire. 2.5 times 4.5 exponent minus 6 divided by 2.65. So this is 4.24 or 4.25. 4.25 times 10 power minus 6 times 10 power minus 6 meters squared. That is the area of the second wire. So I want to find a change in resistance. Okay, let me first find the resistance of the first wire. I'll call it R1. R1 is equal to rho, because it's the same wire, the resistivity is going to be the same. So rho is 3.5 times 10 power minus 7 L 2.50 divided by A, which is 4.50 times 10 power minus 6. So 3.5 exponent minus 7 times 2.5 divided by 4.5 exponent minus 6. So this is 0.194. So let me find the second resistance, R2. Resistivity is the same, 3.5 times 10 power minus 7. Length is 2.65. Then the area is 4.25 times 10 power minus 6. So 3.5 exponent minus 7 times 2.65 divided by 4.25 exponent minus 6. So this is 0.218. 0.218. Of course, this is ohms. So the change in resistance will simply be 0.218 minus 0.194. 0.218 minus 0.194, which is 0.24. So the answer is going to be, is it 0.24? 0.024. So the answer is going to be B. Which circuit symbol represents a microphone? So this one I think is an electric bell. An electric bell. This one is a buzzer. This one is a microphone. This one is a loudspeaker. So the answer is C. A battery with internal resistance is connected to a fixed resistor, an ammeter, and a voltmeter as shown. The battery is replaced by a different battery that has the same EMF but a greater internal resistance. Same EMF, greater internal resistance. What happens to the readings on the ammeter and the voltmeter? Remember that the EMF E is equal to the terminal PD plus the lost volts. Terminal PD plus the lost volts. So the reading of the voltmeter is the PD outside. So the PD outside, which is the terminal PD, is going to be the EMF minus the lost volts. I want you to note that the current through the circuit I is equal to the EMF over total resistance, which is R plus small r. Let this be R, this be small r. So the battery has the same EMF but greater internal resistance, so small r has been increased, which means total resistance here increases. And if the EMF is the same, it means total current decreases. So it means the current in the circuit decreases, but remember the lost volts. Lost volts is equal to that current times R, small internal resistance. So the lost volts decreases because the current has decreased. So the lost volts decrease because the current has decreased, the lost volts decrease. So what happens to the PD? Let me see. As R internal resistance increases, the current decreases. So the voltmeter reading decreases. This is wrong. How about the voltmeter reading? Remember V, so the current has decreased, the lost volts have decreased. The current has decreased, the lost volts have decreased. This increases, internal resistance increases, total resistance increases, the current decreases. Okay? So since it is now a smaller current, we have a greater lost volts. So V or the PDV is going to be the EMF minus the lost volts. So the current has decreased. The current in the circuit has decreased. So if the current decreases, I times R becomes smaller. If this becomes smaller, the current has decreased, internal resistance is greater. Oh yeah. So the current has decreased, but R is now greater. Since R is greater, it means that we are now going to have more lost volts. We're going to have more lost volts, and if this is more, then it means the difference here becomes smaller, so V is going to be decreased. The answer is going to be A. Automatically, it doesn't stay the same. Although it is quite confusing, it does not stay the same since the current has decreased, but remember R has increased. Since the current has decreased and R has increased, it means the lost volts is now greater. Since the EMF did not change, it means the PDV or the terminal PDV must be decreased. So the answer is going to be A. It cannot be the same. 4 potential divider circuits each consist of a battery, EMF 9 volts, and negligible internal resistance connected to a combination of resistors. Each of the resistors in the circuits has a resistance X or 2X. Which circuit has the largest output voltage? Largest value of V. So let's check here. First of all, I'm just going to use a potential divider formula, that is V out is equal to R1 over R1 plus R2 times the voltage supply, which is 9. So here, V here is going to be X. This is going to be equal to X over total resistance, which is x plus x, which is 2x times 9. And I think this is 4.5 because x cancels out. This is times. Then here, V here is going to be resistance is 2x divided by total resistance, which is 2x plus x, which is 3x, then times 9, which is 2 over 3 times 9. I think this is 6 volts. Let's check this one. These are in parallel, so resistance decreases. So we say product over the sum, x times 2x. So we have x times 2x divided by x plus x. Then on this, I'm going to add another resistance. Okay, this is going to be 2x squared divided by x. So this is x plus 2x divided by 3x. So this is going to be 2x over 3. So the resistance here is 2x over 3. But then total resistance, our total is going to be 2x over 3 plus x, because the other one is in series. And I think this is 5x over 3. Let's find V. V is going to be the resistance there, which is 2x over 3 divided by total resistance, which is 5x over 3. So 3 cancels out, then times 9 volts. Using the potential divider formula, 3 cancels, x cancels. So you have 2 over 5 times 9. This is times 9. So 2 over 5 times 9, I think this is 3.6 volts. Let's check this one. Resistance, of course, these are in parallel. We have already seen this as 2x over 3. When we add it to this, we get total resistance as 5x over 3. So the PD across here is going to be equal to x divided by total resistance, which is 5 over 3x, then times 9. So x cancels out. So the 3 goes up. You have 3 over 5 times 9, which I think is, what is that? 3 over 5. 3 divided by 5 times 9. That is 5.4. So we have now seen that the answer here is going to be B, which is 6 volts. Okay, sorry I have to take longer because I try to explain more, give more explanation sometimes. The voltmeter is connected into a circuit with the polarity shown. The sliding contact is moved to end P of the potentiometer and then to end Q. What are the two readings of the voltmeter? When I bring the voltmeter at point P, it will only give me a voltage. It will be something like this. Automatically it will read 3 volts. When I bring it at end P, it will just read 3 volts. So at P, it must read 3 volts. So we ignore A and B. When I take it at Q, so I take the voltmeter at Q. So if I take it at Q, I'll have something like this. So it's like the voltmeter is giving the potential between these 2 points. And the potential here, if this is 3 volts, it's like the potentials are going to be adding up. If this is 3 volts, so it's like the potential here, because this is, okay, I'll just use Kirchhoff's laws. If I use simply Kirchhoff's laws, I consider a loop which is clockwise. So the EMF, the potential, the voltmeter will give the total EMF here, which is 3 volts plus 3 volts. Because this is a longer bar, this is a longer bar, so it's like 3 volts plus 3 volts, which is 6 volts. So the answer here is going to be 6 volts. So the answer is D, 3 volts and 6 volts. Particle physics, a proton has mass mp and charge plus e. What are the mass and charge of an antiproton? Of course, the mass should be the same. We ignore A and B. Then an antiproton has an opposite charge, same mass, opposite charge. So the charge, since the other one has E plus E, the other one must be minus E. So the answer is going to be D. Uranium nucleus has 92 protons, 143 neutrons. The nucleus emits a total of 3 alpha particles, 4 beta particles to form a nucleus X. So let's write the equation. Uranium 2, I think 143 plus 92 is 235, 92. This is giving us 3 alpha particles, 3, 4, 2, plus 4 beta minus, beta is 0, minus 1, and plus X. So proton number, this side we have 3 times 2, which is 12. That is nucleon number, plus 4 times 0, which is 0, plus, I'll call this one A, plus A. So we must subtract 235 should be equal to 12 plus A, which means A is going to be 235 minus 12. And I think A is going to be 223. 223. So A is wrong, B is wrong. Then B, I'll have the proton number. We have 92 on this side equals to 3 times 2, which is 6, plus 4 times minus 1, which is minus 4, then plus B. So this is going to be 90, B is going to be 92 minus 2, which is 90. So B would be 90. So the answer is D. And lastly, which statement about a proton is correct? Of course, a proton is a hadron. It is a baryon because it has quarks. A proton is a baryon but not a meson. That is very true. A proton is a baryon but not a meson. It is a baryon and a hadron. A proton is a meson, it is not a meson. A proton is a hadron and a meson. A proton is a hadron, which is true but not a meson. It is a baryon. A proton is both a meson and a baryon. That's not true. A proton is a baryon and a hadron. So the answer is A. Okay, sorry for it being longer than 1 hour and 15 minutes, but at least I've tried. Until next time, bye bye.